Welcome to the presentation on efficient solution to count vowel-only strings in given ranges. In this presentation, we will walk through an efficient approach to solve the problem of counting vowels-only strings within given ranges of indices. This will be implemented in C++. Let's start with the problem statement. We are given an array of words and an array of queries. Each query asks you to find the count of vowel-only strings within a specific range of indices. A vowel-only string is a string that contains only vowels, the characters A, E, I, O, and U. Our task is to determine how to efficiently handle multiple queries on this list of words. Now let's discuss the approach to solving this problem efficiently. First, we pre-process the words list to identify vowel-only strings. For each word, we check if every character is a vowel. Next, we create a prefix sum array where each entry stores the cumulative count of vowel-only strings. Finally, for each query, we simply calculate the difference between two entries in the prefix sum array to get the count of vowel-only strings in the specified range. To identify vowel-only strings, we iterate through each word in the list and check every character. If all characters are vowels, the word is marked as a vowel-only string. If any character is not a vowel, we mark the word as non-vowel and move on to the next word. To efficiently answer queries, we build a prefix sum array. This array stores the cumulative count of vowel-only strings up to each index. The key idea here is that once we have this array, we can quickly compute the result for any query by using the formula result equals to count right plus 1 minus count left. To answer each query, we use the prefix sum array. For a query with the range left, right, we calculate the number of vowel-only strings in that range by subtracting the cumulative count at index left from the cumulative count at index right plus 1. This gives us the desired result in constant time, making it efficient even for large numbers of queries. Let's look at the C++ code implementation. First step is pre-processing the words list. We check each word to see if it contains only vowels. If it does, we update the prefix sum array to reflect the number of vowel-only strings encountered so far. Here we initialize the prefix sum array and an unordered set to store the vowels. In the next part of the code, we loop through each word and check if it's vowel only. For each word, we iterate through its characters to check if each one is a vowel. If all characters are vowels, we increment the count in the prefix sum array. Now let's move to the final part of the code, where we answer the queries. For each query, we simply compute the difference between the relevant prefix sum values to get the count of vowel-only strings in the specified range. This approach ensures that each query is answered in constant time. Let's analyze the time complexity of this solution. Pre-processing the words list involves checking each character of each word, which takes big O of n times m time, where n is the number of words and m is the average length of the words. Answering each query is done in constant time due to the prefix sum array. Therefore, the total time complexity is big O of n times m, where plus q, where q is the number of queries. Next, let's discuss the space complexity. We require space for the prefix sum array, which is of size big O of n. Additionally, we stored the words list, which also takes big O of n space. Therefore, the total space complexity of the solution is big O of n. In summary, the time complexity of the solution is big O of n times m plus q, which is efficient given the constraints. The space complexity is big O of n, which is optimal for storing the words list and the prefix sum array. This makes the solution both time efficient and space efficient. The key advantages of this approach are its efficiency and scalability. The use of the prefix sum array ensures that each query is answered in constant time. The pre-processing step scales well with the number of words, and the overall space usage is minimal, making the solution suitable for large datasets. To conclude, this approach efficiently solves the problem of counting vowel-only strings within given ranges. By combining pre-processing with a prefix sum array, we ensure fast query responses. This solution is highly scalable and well suited for handling multiple queries on large datasets. Thank you for your attention. I hope this presentation helped you understand how to efficiently count vowel-only strings in a list of words using prefix sum arrays. If you have any questions, feel free to ask.